Elastic and inelastic collision.
When two bodies forcefully come in contact out of a sudden, we say collision has occurred. There are other types of collision, but with this topic, we'll treat just the elastic and inelastic collision. Elastic collision. Collision is termed elastic when after two bodies collide, they tend to move at different velocities. A collision is termed inelastic when after collision, the two bodies combine and move with the same velocity. When two bodies collide, momentum is always conserved, but kinetic energy may or may not be conserved. A collision in which both momentum and kinetic energy are conserved is known as elastic collision, whereas a collision in which momentum is conserved but kinetic energy is not conserved is known as inelastic collision. Some differences between elastic and inelastic collision. There are three equations that are fundamental so far as collision is concerned. And these equations are the conservation of linear momentum and the conservation of kinetic energy. We've already treated conservation of linear momentum, so let's zoom into kinetic energy. Kinetic energy is the energy of a body by virtue of its motion, and it is expressed as half times mass times the square of the velocity. For conservation of kinetic energy, since the bodies are in motion, then kinetic energy is present. For elastic collision, both of the equations remain the same. The conservation of linear momentum remains this way, and the conservation of kinetic energy remains the same. For the conservation of kinetic energy, let's introduce half here, then square the velocity. Introduce half here, square the velocity. Now let's square the velocity, then introduce half. So that's how it will be for inelastic collision. Since the velocities are the same after collision, and this is what happens after collision. Now the velocity of the body A is equal to the velocity of the body B. So these velocities are the same. Now let's term it as it will be just a velocity. The equation will turn to m, which is the mass of body A times. Now let's factor the velocity out. That's how the equation will be.
It's question time!
Two bodies of mass, so mass of body A, mass of body B. First one is 5 kg, second one is 3 kg. For the velocities 0.25 respectively. So the first one, velocity of body A is 0.25 meters per second, and the velocity of body B is equal to 0.75 meters per second. If the collision is perfectly inelastic, so the next clue is that the collision is inelastic. We are to find the velocity of the two bodies after collision. We are also to find the total kinetic energy of the system before and after collision, and then calculate the loss in kinetic energy. So for inelastic collision, the conservation of linear momentum is given as mass of the first body, that is 5. So let's just input them. So we have 5 multiplying the initial velocity plus 3 multiplying 0.75 is equal to 5 plus 3. Now we 0.4375 meters per second. Now for the second aspect, we are finding the kinetic energy before collision. Now kinetic have So this is before collision. Let's just put the values in. We end up getting half times 0.3125 plus 1.6875, which is equal to half of 2, 1. So 1 joule, since it's energy. After collision, the velocities are the same, so that is going to be so we have half mass A is this is going to be 0.7656. Now the loss in kinetic energy is the kinetic energy before collision. So kinetic energy before collision minus the kinetic energy after a collision. Now before the collision we had 1 minus after collision is now 0.7656, and that is 0.2344. Things to look out for in solving questions under this topic.
Sin pero.